Alright, so let's look at the inverse trig functions today. So we're going to look at inverse trig graphs. Now, for those of you, by the way, who haven't made up the test, I'd like to get those tests done so I can hand them back tomorrow and all that good stuff. So if you could get in and get that test taken out tomorrow, you have to have it done by tomorrow afternoon. So 2 of you came this morning, that's great. The rest of you need to come and get that done. And I'll come in at 7:30 tomorrow for those of you who need some extra help before you take it if you want to do that. All right, so we're going to graph our inverse trig functions. We're going to start with sine today. So we're going to look at sine x. So y equals sine x. And I'm going to keep losing my screen because I apologize. I left my white cord last night at our cross-country banquet, and I'm using another one, and it doesn't work very well. All right, so we're going to look at y equals sine x. And then we are going to look at its inverse, which we call, you ready? Here we go. It's real complicated. We call it inverse sine. But the AP exam calls it something else. Go figure. We call it arc sine. Arc sine. That's what's referred to on the AP exam. Anytime you see arc sine, you need to know that really means inverse sine. And you are responsible for these graphs, so you need to graph them with me. You will be tested on them. So it looks a little different. It's a little awkward, okay, because we're going to have to memorize some things. Because one of the reasons I cover this is because your calculator, what I'm about to teach you today, this is how your calculator does it, okay? Because one of the things we're going to notice is when we do the inverse of sine x, we get a function. When you graph all of inverse sine x, you get something that's not a function. So you actually have to restrict part of the graph to produce something that will be a function that'll pass the vertical line test. So it gets a little bit complicated. I would say this trimester, this is the hardest thing we're doing. So you need to make sure you listen up. Really good today. Because this is probably one of the most confusing things I think we do. So here we go. Let's go ahead and start with graphing sine x. It's supposed to be a good review for those of you who haven't taken the test yet, I guess. And you need to graph it really well. I mean, like very accurate. And the other thing you need to do is you need to make sure you got plenty of room at the top and bottom here. Plenty of room. All right, let's start with sine. And I'm going to go out to 2 pi. So we'll go out a ways, I guess. There's pi. There's pi over 2. There's 3 pi over 2. Negative 2 pi. Because I didn't take my time last hour, I butchered this, so I'm going to really take my time here to make sure I don't confuse anybody. All right, now, I actually want you to label your y-axis from negative 2 pi to 2 pi now. So we're going to do our y-axis the same way. You'll see why in a second. Okay? So I'm going to go up to 2 pi. I'm going to go half of that's pi. Half of that's pi over 2. And that's 3 pi over 2. And same thing down here. That'll be negative 2 pi. Negative pi. Negative pi over 2. Tonight, when we start, I'm going to use this today to kind of introduce what inverse trig functions are. But tomorrow, specifically, we're going to be working a lot with the calculator. And there's going to be some things you need to know about these values as decimals. So let's go ahead and write those down. You do need to know that pi radians is really what as a decimal? What is pi radians really what? And I'm not asking for the degrees. I know what it is in degrees. It's 180. Big whooping deal. I'm glad we know that. But we're not doing degrees anymore. Okay? So what is pi radians as a decimal? It's 3.14. I know, it's rocket science. All right, what about pi over 2 as a decimal? You need to know this, and you probably need to have it memorized. 1 point something. You can use your calculator if you like. 1.57. That's what I would learn. We're going to use that tomorrow, believe it or not. Okay, next one, 3 pi over 2.
4.637.
Yeah, 4.71 is what I use. That's usually what you use on the AP exam, so 4.71. 2 pi.
6 pi.
Be familiar with those decimal values because we will use them tomorrow. Okay, and it'll show up a ton on the homework. In fact, almost all the homework problems we do tomorrow are going to be dealing with those decimal values. All right, here we go. We're going to start by graphing sine. Now, I'm going to graph sine in blue. I'm going to use two different colors. You don't have the liberty to do that unless you got a pen. But it would help if you've got two things to contrast here. Make one darker, one lighter. All right, so sine starts where? Sine starts in the middle. And it goes up to what? It goes up to 1. Now, I've got pi over 2 there, so where's 1? A little bit less than that. So let's go about right there. So this thing's not going to go very high, just because of the way I've got it graphed. Then it goes back to the middle, and then it goes down to what? -1 was about right there. And then back to the middle. Whoops, sorry. Right there. And then it goes back to the what? Middle. So you get, looks like this. Okay? And you can graph a little bit over here. You don't need to graph a lot. We actually don't need 2 full periods to do what we're going to do. I'll just graph the negative pi. We shouldn't even have graphed all that. Okay. Now, here's my question. What is an inverse? It has something to do with driving. Think of it like this. When we drive forward, the next thing you need to learn how to do is drive what? Backwards. Now, inverse does not mean completely the opposite. In fact, inverse only means the opposite when you're adding and subtracting. If you do addition, okay, and when you're doing addition, the opposite of addition is what? Subtraction. But
just make it negative or anything?
It has something to do with the -1 exponent. That's the notation. That's not what it is, but that has something to do with notation. So that's why we have the -1 exponent here. So addition and subtraction, we do an opposite. That's how we do an inverse. What about multiplication and division? Because we don't do an opposite there. How do you do an inverse for multiplication? What is the inverse of multiplication? Division. But what do you do to get division? You do a reciprocal, okay? So a reciprocal. So adding its opposite, multiplication its reciprocal. What about for logs? E to the x. It's an exponent, okay? So for logs, it's e to the x. What about for trig functions? Well, if it's sine, what's inverse sine? But my question is, and this is where I want to really kind of nail this down, is what does that actually mean? I mean, what does inverse sine really mean? I mean, you kind of get it for addition. Addition, the inverse is opposite. I get that. That's subtraction. For multiplication, the inverse is reciprocal. I get that. For logs, I get that. It's an exponent. But what does it mean for trig? Well, you got to go back really to the basic definition of an inverse. And here's what an inverse is. An inverse, actually, write this down. I'll put it up here in black. An inverse, there's 2 ways to define it algebraically. First of all, it means to switch x and y. Switch x and y. Now, geometrically, what that means, because that's what we're doing right now, is we're doing some graphing, so that's the geometric version of what we're trying to do. So to get inverse sine x, you actually switched x and y. Let me prove that to you. Let's just prove algebraically. So if I switch x and y, you get x equals sine y. And if you resolve for y, we know that we're going to have to use inverse sine. So you look at this and you say, okay, take the inverse sine of x, take the inverse sine of y, of sine y, and the inverse sine and the sine cancel out, and you end up with y. I mean, that's algebraically what happens.
So is it like this?
Huh?
Like this? Like up and down?
It is going to go up and down, but we're going to have to do something to it, and I'll explain here in a second, but you're definitely thinking on the right track. What happens when we switch x and y? Here's what happens. You get a 90-degree rotation, and actually what happens geometrically, it is reflected. Write this down. It reflects over y equals x. It reflects over the line y equals x. You need to know that. That's big time. Come on, quit doing that stupid black cable. Okay, so it reflects over y equals x. So let's do this. Let's take each point. Now I've got it plotted out. That's why we did this from 0 to 2 pi, negative 2 pi to 2 pi here also. And let's plot this out. Now I'm going to use a different color. I'm going to use, we did blue. We'll do black now. Okay? Let's take each point and let's switch x and y and see what happens. All right, 0, 0. What does that become? 0, 0, 0. That one's easy. Pi over 2, 1. What does that become?
0 pi.
Uh-uh.
So it becomes 1 over pi.
All right, 1's about right here, so that's going to become 1 pi over 2, so that's roughly here. Okay, next one. Pi 0 becomes what?
0 pi.
0 pi. 3 pi over 2, negative 1 becomes what?
Negative 1, 3 pi over 2.
Negative 1, 3 pi over 2. It's roughly right here. And what about 2 pi 0? 0, 2 pi. Now, I'm going to dash this in. Let's go back on the negative side. Let's do some of the negatives real quick. Do not solid draw this in yet. I'll tell you why in a second. Let's go back on the other side. This was negative pi over 2, negative 1. What would that be? Negative 1, negative pi over 2? Okay. What about negative pi 0? 0, negative pi? All right, here we go. I'm going to dash this in. Arc that better. I'm going to arc that a little bit better. Should do this. Let's see. Should go like this. Sorry. I wish I could erase that. Darn it. Can you disregard those little black ones there? Is that okay?
It needs to go like under that.
Yeah, it's got to go under it. Dad, no. Yeah, it's got to go under. Gosh, I wish I could erase those. I don't know if I hit this, it's going to erase everything right there. So just have to deal with it. All right. Now, the reason I have not solided this graph in, I haven't drawn it solid, is because right now, if you imagine, does everybody understand this is going to keep going up and down? It's going to wiggle up and down the y-axis. And it's going to go between what and what? I want you to give me some observations, first of all, just some initial observations about sine and inverse sine. What are some things that you notice happens when I switch x and y? It's actually reflected. It flips over y equals x. And let me go ahead and draw that in. I'll use what color have I not used? Let's use green. If you see it here, it looks like this. There's a perfect reflection over the line y equals x. It's folded. That blue folds over the line y equals x, and it'll match up with the black. Okay? I'll draw that better in a second. You'll see that better. But what else? That is huge. That's the biggest thing I want you to see today is the domain and range get flipped. Now, what was the domain for sine? Domain was all real numbers. We got to talk about this because this is the part where it gets a little confusing. What about the range? Negative 1 to 1. Get ready to do something with the calculator. So if I come over here to inverse sine, what's the new domain? What's the new domain?
Negative 1 to 1.
Negative 1 to 1. Get your calculator out right now.
Are they in here?
Yeah, they're in there. You'll have to turn it down. Get your calculator out right now. Here we go. Type in inverse sine. It says domain's negative 1 to 1. What that means is that you can only do the inverse sine of values between negative 1 to 1. So let's try it 0. Do inverse sine of 0 real quick. What do you get?
0.
You should get 0 because we know sine is 0, 0. Do inverse sine of 1/2. Inverse sine of 1/2. What do you get?
0.5.
I bet if you go pi divided by 6. What's pi divided by 6? Do pi divided by 6 real quick. Same thing, because inverse sine of 1/2 should be pi over 6, but your calculator doesn't give you pi over 6, it gives you a what? That kind of sucks, but that's life. Okay? Do inverse sine of 1. Should be pi over 2. See, that's what you get. What do you get? 1.57. Now do inverse sine of 2. Why? Because your domain, your inverse sine graph only stays between what and what? Now tell me why on the unit circle you can't take the inverse sine of something bigger than 2 or something, or anything bigger than 1 and anything less than negative 1. Because your unit circle, the greatest radius is what? So sine can never be bigger than 1, it can never be smaller than what? You can't take the inverse sine of anything bigger than 1 and anything less than -1. So if you get, for example, when you get an equation tonight, if you get this, and you have sine x is equal to 3, you can automatically put no solution. Why? Because you can't do the inverse sine of 3, because it's not in the domain. You're going to have to memorize these domains and ranges to do these problems. Okay, especially the calculator problems. Calculator problems are going to be a royal pain. I'm going to tell you, I don't even like doing the calculator problems because you have to think about all this domain and range stuff. The range is actually the most important part. Typically, we think of the range as the part. It's like, it's cool, we can say what the range is. The range becomes the most important part here because the range is actually what the calculator gives you as answers. Range is output. Everybody say that with me. Range is what? So when you get this calculator, it's actually giving you the correct range values. But here's the deal. Now let's go to the range. We are not going to put all real numbers for the range. You need to memorize this. Get ready. It is on your quiz. It is on your test. Here we go. The range is not all real numbers. Can somebody look at that black dotted thing and tell me which part that I should actually draw in solid so that it passes the vertical line test, and you will have your range. Look along the y-axis. Which part should I actually make solid so that this thing passes the vertical line test? Oh, look at me. Look at the y values. From what to what can I draw this black part and make it solid so that it'll pass the vertical line test?
Like on each side of the, only one on each side of the y-axis. You can go one half a period.
You can go half a period, basically. How much? I want to know exactly what y values.
Negative pi over 2 to positive pi over 2.
Start right here. I'll do it in black. If I go from here, I was supposed to go under. Who cares right now? I'm just going to do it. If I go from here to here, does it pass the vertical line test?
Yes.
Once I go past pi over 2, what happens?
It fails.
It won't pass the vertical line test.
Oh, yeah.
Do you see it?
Is it no longer a function then?
No longer a function. We only do things in calculus as functions. So what we have to do, and this is going to be true for all three of them, and they're not all the same. That's what sucks. You got to memorize it. And this is what the calculator will give you. And I'm going to prove it to you in just a second. Okay? It only gives you answers between negative pi over 2 to pi over 2. I'm going to prove that to you right now. Take your calculator out.
Technically, couldn't it also be pi over 2 to 2 pi over 2?
The calculator won't give you that, though. You're going to have to use reference angle and do it yourself. Your calculator only gives you negative pi over 2 pi over 2 ever. Because it will only, your calculator is based on the idea that it has to be a what? Function. It only says x can be paired with only how many y's? One y. It will not do x paired with two y's. It only gives you one answer. Your calculator, when I do inverse sine, have you ever seen your calculator give you more than one answer with inverse sine? But do we know there's more than one answer? In fact, on the unit circle, how many times can sine be negative in just one rotation? Why? Just one rotation. How many times can sine be negative? Let me ask it again. How many times can sine be negative in one rotation? Twice. How many answers did your calculator give you now? It's only going to give you one. Now let me ask you this. How many times can sine be negative if I keep going? An infinite number of solutions. Is your calculator going to give you all those? Guess who has to go find them? You do. Your calculator. And here's the thing. It sucks. It really does, because your calculator is only going to give you one, and if you know there's two, you get the one from your calculator, you got to go grab the other one yourself. And here's what's really frustrating. Your calculator, knowing that this is true right now, let's say tonight or tomorrow, because we won't be to the calculator part tonight, but tomorrow I say I only want the answers between 0 to 6 pi, 0 to 2 pi. Is everybody with me? 0 to 2 pi. One positive rotation. What if it gives you a negative answer? You have 0 answers so far. So if you get a negative answer with your calculator, you're sitting there saying, well, wait a second here. My directions say my answer has to be between 0 to 2 pi. I've got an answer that's not between 0 to 2 pi, but it is an answer. So what you're going to have to do is actually use that answer to find the reference angle so you can go grab the two that you actually want. So it gets to be a little bit of a pain. Okay? Not gonna lie. So,
why we
the
can't
good
do
news
them.
tonight is we're just gonna learn the inverse trig functions. And I'm gonna tell you right now, this is absolutely all over the AP exam. So I've got to teach this really well. And here's the good news. I will. So we're gonna spend the next 4 days doing it just to make sure that I get it done really well. Because it is new for most everybody in here. All right. So this range, let me prove it to you. Go sine, inverse sine. Let's do inverse sine of -1/2. Do inverse sine of -1/2 and look what happens. There you go. You get the negative answer. But in my directions, it says I want the answers from 0 to 2 pi. So what you're going to eventually have to do is you're going to have to look at that answer. You're going to have to get a reference angle off that answer, and then go find the two places between 0 to 2 pi where it's negative. So this won't even be an answer. You'll look at this and be like, oh, dang it, that's not even an answer. That's just a reference angle. And so you're going to have to interpret that. You're going to have to know your calculator is always giving you answers between, look at it, it always gives you answers between negative pi over 2 to pi over 2 on your unit circle. Okay, and we'll practice this a lot tomorrow. All right?
Way to get these answers in radians.
That isn't radians. If I do, here's the deal. Heidi, tonight, we're not going to use the calculator. Because -1/2, in fact, I'm going to show you how to do this in a few minutes. You can do that without the calculator. Because you know your unit circle. You know where sine's 1/2. You should know that's pi over 6 reference angles. So if you know that's a pi over 6 reference angle, then the next step is to figure out where sine's negative. And then you're going to look at it and say, well, I know that's quadrant 3, and I know that's quadrant 4, and then you sit there and say, okay, two answers. My two answers would be, all right, quadrant 3, that would be 7 pi over 6. Quadrant 4, that would be 11 pi over 6, done.
Oh, okay.
That's going to be the easy part. Without the calculator, it's easy. With the calculator, it gets a little hard. That's what I got to really hammer, because the calculator portion of the AP exam is the harder part, I think, in my opinion. And usually every year. Last year was the first year I've ever had a class say the calculator part was easy. But in the other 11 years I've taught this, they always say the calculator part's harder. I think it's going to be back to the other way this year. Okay. All right. Does everybody see that road there? Okay. Memorize this. Memorize this. Memorize this. So tomorrow when we get to it, you've got it. All right. Let's do inverse cosine. Inverse cosine. All right. I'm going to go a little faster now. I want you to graph cosine right now. And I want you to see if you can come up with inverse cosine or arc cosine. Cosine to the -1x, arc cosine. Can you come up with what part you would need to sketch so that it passes the vertical line test? So go ahead right now on your paper, turn your calculators off.